Welcome to Ask and Learn.
Here we have a block that's traveling to the right at an initial velocity of 5 meters per second, and it's going to crash into that spring, and you want to find the distance or the compression of that spring before it launches the block in the opposite direction. So that distance we'll say is called SA. We're given the stiffness of that spring as Ka is equal to 200 Newton meters. The mass of the block is 8 kilograms, and the block is experiencing kinetic friction, so the coefficient of kinetic friction is 0.25. So because we're dealing with movement here, there's got to be some sort of kinetic energy going on, and we want to find the distance, and we know that embedded in work is the distance because work is force times distance. So we can use the work energy principle, and that's given as the initial kinetic energy plus the work being done by the forces is equal to the final kinetic energy. Well, when the block strikes the spring, the spring is gonna compress, so the block momentarily stops moving before launching back. So the initial kinetic or the final kinetic energy is 0 because the velocity final is 0. So now we're just left with the initial kinetic energy, which is 1/2 m v1 squared plus the work being done by the forces, and then all of that equal to 0. We're going to call this equation 1. So now let's look at the work being done. So work is force times the distance. So we know that there's a force due to the spring, and there's a force due to the kinetic friction, and both of them are in the opposite direction of the movement of the block. The block is moving to the right, friction in the opposite direction, and the spring's going to compress and launch it with a force in the opposite direction. So we have minus, and then the force of the spring times the distance, so we have 1/2 K, the stiffness of the spring, times SA squared, minus the force due to friction, which is coefficient of kinetic friction, times the normal force. The normal force is equal to the weight of the object because they're in the y direction, and those are the only forces in the y direction. So you have mass times gravity times the distance it travels. So if you think about it, initially it's 2 meters away from the spring, and then it'll hit the spring and then launch, or the spring will compress a certain distance to A. So the distance for the friction will be SA plus that initial distance 2. So then we can just plug in some numbers to make it a little easier. So you have minus 1/2 K, which is 200 SA squared, minus 0.25 times the mass times the gravity times SA plus 2. So let's clean this up a bit. So we have minus 100 SA squared minus 19.6 SA minus 39.2. And you get this part by distributing all of this to SA plus 2. So now we can plug this into our equation 1. So now equation 1 will look like this. You have the minus 100 SA squared minus 19.6 SA minus 39.2, and then don't forget the initial kinetic energy, so plus 1/2 mass times the velocity squared, so you have 8 times 5 squared, and all of this equals to 0. So once you clean this up, multiply by a -1 to get rid of the negative in the very front. You have 100 SA squared plus 19.6 SA minus 60.8 equals 0. So to solve for SA, you have to do the quadratic formula. So SA is equal to negative 19.6 plus or minus, and then square root, and all of this is inside the square root, 19.6 squared minus 4 times 100 times minus 60.8, and again all of that square root and the whole thing divided by 2 times 100. So when you plug in all of that into the calculator, you get the distance or the compression of the spring is 0.68 meters.